Hello everyone, my name is Farzad Zarrinfar. I am the Managing Director of the IP division at Mentor, a Siemens business. Thank you for joining me at SEM Israel Virtual Technology 2020. For your background, I sold my old company Novelex to Mentor in 2011. At the time, I was CEO of Novelex. Before that, I have held management positions for IP and semiconductor business at ARC, Sony Semiconductor, Samsung, LSI Logic. I have also had engineering positions at Lockheed Martin and Texas Instruments. I have presented in various conferences worldwide and chaired various IP-based sessions at Design Automation Conference. Recently, I chaired Power Efficient IPs for AI at DAC 2019, and I was keynote speaker in SoC event in China. AI is part of your future and also one of the major drivers for growth in semiconductor industry. A big challenge for AI comes in the form of power efficient IPs, which are enabling SoCs for edge devices. I will talk about market trend for AI based SoCs. I will articulate about a sample IP based SoC architecture for AI. I will discuss critical parameters to help you for selecting power efficient IPs. I will illustrate few IP intensive SoCs for AI applications. I will conclude with an exciting AI based demo which I think you will enjoy. I also thank you in advance for attending this presentation. AI chip development and productization is everywhere. Large system companies like Google, Amazon, Microsoft, Apple, and Tesla are implementing SoCs. Leading IP and IC companies like CEVA, ARM, NVIDIA, Intel, Qualcomm, Samsung, and MediaTek are implementing solutions. Over 50 startups such as Hilo, Habana, Atlazo, GraphCore, Mytech are offering AI chips. AI, IoT, automotive are fueling semiconductor industry growth. According to PricewaterhouseCoopers, AI will likely be the catalyst that will drive another decade-long growth cycle for semiconductor sector. According to McKinsey and Company, AI is opening the best opportunities for semiconductor companies in the decade. According to Semico, total AI SoC design start for the automotive market will grow from 488 in 2018 to reach 904 by 2023. All chips for just self-driving cars will be a $10 billion market by 2024. Obviously, IP business is also growing. This is from $4 billion in 2018 to over $8 billion in 2027. This is based on IPnest. From funding standpoint, according to the Global Semiconductor Alliance, during 2017 to 2019, by far the largest funding dollar have been allocated to AI, which is over $1.9 billion. As you can see, AI chips and associated ecosystem are facing great business opportunities. Ladies and gentlemen, follow the money to AI chips. As you can see from this plot, specialized AI processor IPs are applied from low performance applications such as voice activated devices, i.e., Alexa, to smartphone with about 100 inference per second, to ADAS, which stands for Advanced Driver Assistance Systems, with 5,000 inference per second, to much higher in data centers. Therefore, scalable, flexible, PPA optimized IPs are needed. You can see that processor IPs are complemented with PPA optimized memory IPs such as Mentor's Cool SRAM, Cool Reg, Cool ROMs. I invite you to visit www.mentor.com/product/in-IP to get valuable white papers in this regards. The proper selection of memory IPs are becoming more critical. Therefore, we can see that there is an emergence of in-memory and near-memory computing to maximize the SoC efficiencies. These IP-based solutions are enablers to manage critical parameters such as energy efficiency, cost, latency, reliability, bandwidth, and security for AI chips. Looking at trend-setting AI chip companies, i.e. Graphcore or Mythic or Atlazo or Bitman at high level, you can see a uniqueness about AI chips. These chips utilize a new compute architecture using lots of distributed tile-based computing memory with local SRAM, and also efficient data flow architecture, which are paramount for AI chips. This architecture enables scalability with also efficient communication from each direction. As a result, such architecture delivers various benefits such as fantastic performance, minimized power consumption, and maximum flexibility. Let's take a look at a block diagram of an AI accelerator architecture such as Google's Tensor Processor Unit TPU. This is ideal for machine learning based solution. The TPU includes the following computational resources such as matrix multiplier unit, unified buffer, approximately 24 megabyte of SRAM that works as a register, and activation unit. This is especially designed for convolutional neural network CNN inferencing. The edge TPU is designed for small, low power devices. Such AI accelerator uses PCIe Gen 3 or Gen 4 or Gen 5 IPs to connect with external server, and DDR4 or DDR5 IPs to connect with external memory system. For automotive, ADAS, which stands for Advanced Driver Assistance Systems, is benefiting from AI to automate aspects of the driving process, such as parking assistance, lane positioning, and collision avoidance to enhance the safe operation of an automobile. As you can see, this ADAS system provides warning functions using technologies such as video cameras, radars, LiDARs, and ultrasound monitoring. The advanced AI-based systems now employ video processing algorithms and use multiple video cameras to provide even more accurate event detection and driver alert. On-chip communication is an important segment of the IP business. Ethernet IPs enable communication between ADAS infotainment, cameras, sensors, and other processors. However, to meet the low latency and safety requirements of mission-critical control systems like braking, steering, etc., time-sensitive networking (TSN) is utilized. This is a superset of the traditional audio-video bridging transport (AVB) protocol standard. This includes multi-speed Ethernet MAC IPs. This high-speed Ethernet IP is highly successful for in-vehicle networking (IVN). This is based on IEEE 802.3 standard. Also, CAN bus IP is also instrumental for ADAS architecture. The modern automobile may have more than 70 ECU for various subsystems. Typically, the biggest processor is the gateway ECU. Others are used for transmission, airbags, anti-lock braking system ABS, radar, cruise control, EPS, which stands for electronic power steering, audio systems, power windows, and etc. The CAN IPs are designed and used for their communication. All sensors and processors also utilize SRAM and ROM IPs with optimum PPA, power performance area. Let me briefly cover IP solution that Mentor offers for ADAS. Mentor's soft Ethernet IP portfolio supports speed grades from 10 million bits per second up to 10 gigabit per second for in-vehicle networking. We offer CAN 2.0 IP, both 2.0A and 2.0B. We support 11-bit and 29-bit identifiers. For sensors and processors, we offer PPA optimized Cool SRAM, Cool Reg, and Cool ROM. For housekeeping, we offer a rich portfolio of microcontrollers such as AD51 EWIP. USB such as 2.0 IP is great choice for functions such as debug port. The USB port can also be used to charge personal devices. From a software standpoint, AutoSAR 4.0 development platform providing the tools and runtime software you need to ensure the fastest time to market. This is developed for automotive safety integration level, well known as ASIL requirements. The modules are confirmed to meet ISO 26262 requirements and ASIL A, B, C, D use cases. These are value-added IPs that can minimize time to market, minimize cost, minimize power dissipation for using lighter weight batteries, and help to differentiate your ADAS products. I would like to share with you the architecture of several IP-based SoCs in AI-based applications. For example, QuickLogic performed their local sensing to minimize AI-based data traffic. This was involved with coupling Mentor memory IPs with ARM's Cortex M4 with FPU. Customer stated Mentor Coolest RAM 6D offered lowest leakage and active current, which allows ultra low power always on processing for audio sensor data. This is fantastic. Microsoft presented at DAC 2016. They illustrated the use of Coolest RAM 1T IP in bulk CMOS with no additional mask layer to achieve minimum die size and minimum die cost. This design also used ultra-wide buses to achieve great bandwidth, which is critical for imaging applications. Also, because of ultra-wide embedded buses, there was no need for ultra-fast clock frequency, which minimized the chip's power consumption. Shortest time to market was achieved due to the fact that memory IPs were generated by MemQuest compiler. Using AI-based Connect, gamers can experience a great convenience and control using Xbox. Augmented reality and virtual reality have become more relevant in a world where people cannot meet in person as easily. Devices such as Microsoft HoloLens 2 with power of AI on the edge and low power IP technology enables users to cut the cord and wirelessly move about freely. This enables people to immerse themselves in a virtual world with complete gesture recognition and eye tracking. This was presented at DAC 2019 conference. Mentor offers Coolest RAM and Cooled Reg IPs, as well as offering special consulting services such as viability analysis and building self-test / building self-repair services. This enabled our SoC partner to minimize power consumption, maximize SoC efficiency with shortest time to market, which was unprecedented. Microsoft also discussed an AI-based SoC with powerful gesture recognition capabilities at DAC conference. Mentor's coolest RAM 1T IP in this target process node enabled customer to drop SRAM size in half, reduce die cost, and bring this powerful technology to a commercial application as well as gaming enjoyment. This was a fun AI application using gesture recognition algorithms and body tracking, which drove robots. AI inferencing for Skelton diagram was utilized. At the end, in one slide, I like to present the organizational value that we offer to our customers. 1, verification services. 2, yield enhancement services. 3, system engineering services. 4, soft IPs and portfolio of memory IP offering from 22 nanometer up to 180 nanometer with optimum PPA. This is complemented with digital IP implementation services. 5, learning services.
Okay, nil.
Getting better, don't you think? That was in 2. Your test shot. Getting better, don't you think? Wall Street will gradually become faster and faster. You are playing perfectly in sync with Orpheus. Good riddance.
Look at the list of robot. It's ridiculous.